Greetings and welcome to the Introduction to Astronomy. In this week's exploration of the solar system, we will talk about the Mars Orbiter mission and look at its study of the red planet. So let's go ahead and get started. Reaching another planet is one of the most difficult challenges in space exploration. It requires precise navigation, complex engineering, and years of planning. In 2013, India took on that challenge for the very first time. The result was the Mars Orbiter mission, also known as Mangalyaan, a spacecraft that would carry India into the community of nations exploring the red planet. The Mars Orbiter mission was launched by the Indian Space Research Organization, or ISRO, in November of 2013. Its goals were twofold: to demonstrate the technology needed for interplanetary travel, and to carry out a set of specific scientific observations at Mars. After a journey of nearly 10 months, the spacecraft entered orbit around Mars in September 2014. With that success, India became the first nation to reach Mars on its first attempt, and the fourth space agency overall to place a spacecraft in Martian orbit. Although it carried scientific instruments, the mission's primary goal was technological. It tested deep space communication, long-duration spacecraft operations, and the complex navigation required for a journey between planets. These capabilities were essential for any future planetary missions, both to Mars and beyond. In this way, the Mars Orbiter mission marked an important step in India's growing role in space exploration. Alongside its engineering goals, the spacecraft carried several scientific instruments. One of its main goals was to study the surface and atmosphere of Mars using infrared light. In simple terms, this meant measuring how the surface absorbs and reflects heat, how the temperatures vary across the planet. These measurements helped scientists map surface materials, track seasonal changes, and better understand the Martian climate. The spacecraft also observed dust storms, clouds, and the distribution of gases in the upper atmosphere. One of the mission's most intriguing goals was the search for methane in the Martian atmosphere. On Earth, methane is often produced by living organisms or geological activity. Detecting methane on Mars could hint at active processes beneath the surface. Although the results were limited, the mission helped refine how scientists search for methane and other traced gases on Mars. The Mars Orbiter mission operated far longer than its planned lifetime, continuing to send back data and images of Mars for years. More importantly, it demonstrated that interplanetary exploration was within India's reach, and that complex missions could be accomplished with innovative, cost-effective engineering. It marked a turning point, opening the door to future planetary explorations by ISRO. The Mars Orbiter mission showed that exploration is not limited to a few nations. With determination, ingenuity, and careful planning, new voices can reach across the solar system. Every successful journey to another world expands not only our knowledge, but the community of explorers who share it. So that concludes this week's exploration of the solar system on the Mars Orbiter mission. We'll be back again next week for another exploration of the solar system video. So until then, have a great day, everyone, and I will see you in class.